Hello everyone. This video would focus on conic section, specifically on parabola, and this is the fourth part. In this part, we are given the vertex and the directrix of a given parabola, and we're supposed to determine its equation, and we're supposed to sketch the graph. Before we go over this example right here, let's have a review on the basics of parabola with vertex at 0, 0. There are 4 cases of a parabola with vertex at 0, 0, and this is the first case right here. Before we go over the details of the first case, let's have the parts of a parabola. These are the parts of every parabola. The first one is the directrix, which is represented as a broken vertical line right here. And this is the vertex. Again, our vertex is at the point of origin 0, 0. This is the focus, and this is the line of symmetry. Please remember that the distance from the directrix to the vertex is represented as P. So I'm just going to go ahead and label that up here. So this is represented as letter P. Now the distance from the vertex to the focus is also represented as P. So this is another P right here. This tells us that for every point on the parabola, the distance from the directrix to the focus would always be the same. Meaning if we take this point right here, the distance from the directrix and the distance from the focus, these two will be the same. And that is true for all the points on the parabola. Now we also remember that if we draw a line perpendicular to the focus passing through the, or perpendicular to the line of symmetry passing through the focus, this is what we call as the Lattus Rectum. So I'm just going to go ahead and label that up here. Now we remember that the distance from the one of the endpoints of the Lattus Rectum to the focus is 2p. And the distance from, again, the other end of the Lattus Rectum and the focus is, again, the distance is 2p. So pretty much the length of the Lattus Rectum is 4p. Now we also remember that for every parabola, it will open towards where the focus is. So in this case right here, since our focus is on the positive x-axis, so the parabola will open on the right. Now, the formula that works for the first case is y squared equals 4px. So this is the formula for the first case. Now let's look at the second case. In the second case, the parts of the parabola would always be the same. We have the directrix, the vertex, the focus. This is the line of symmetry, and this is our parabola right here. If you notice, the parabola on the second case opens to the left since the focus is on the negative x-axis. Again, remember that the parabola opens to the side where the focus is. The formula that would work for the second case is y squared. It's pretty much the same thing as the first one. That's y squared equals 4px. So this is the formula that would work for the second case. Now let's move on to the third case. For the third case, the parabola opens upward since the focus is on the positive y-axis. We also have the directrix. Again, we have the vertex at the point of origin 0, 0, and we have here the axis of symmetry. Now, the formula that would work for the third case, again, whenever the parabola opens upward, is x squared equals 4p y. So this is the formula for the third case. Now let's move on to the fourth case. In case 4, our parabola already is facing downwards. It opens downward because the focus is on the negative y-axis. And we still have the same parts. We have the directrix, we have the vertex, and we have the focus, and the line of symmetry is the y. The formula for the fourth case is pretty much the same as the third case. That is x squared equals 4p y. So this is the formula for the fourth case. So these are the four cases of the parabola with vertex at the point of origin, or 0, 0. Okay, going back to the problem right here, we're supposed to determine the equation of a parabola with vertex at 0, 0, and with directrix at x is equal to -2, and we're supposed to sketch the graph. We are going to sketch these, plot the point for the vertex and sketch the directrix here. So the vertex is at 0, 0, so we label this as letter V. And then the directrix is x equals -2. So -2, that's going to be -1, -2. So this is where the directrix is going to sit. We remember that the distance from the vertex to the directrix is represented as P, and at the same time, the distance from the vertex to the focus is also the same distance as the directrix. So we can go ahead and say that our focus is actually located across the other side. From the vertex to the focus here would also be 2 units. So that's 1, 2. So I will put this and label this as our focus, so that we can go ahead and say that this parabola is going to open to the right since the focus is on the right. So then we can go ahead and say that this is an example of case number 1. Okay, so looking at this, the value of P is actually positive. The reason why it's positive, because it's going to the right. So then we can go ahead and write that up here, that our P value is positive 2. So then we can go ahead and write the equation of this parabola that we have in this problem right here. So since this is case 1, our equation is y squared is equal to 4px. Now we already have a positive 2 as a p, so we plug it in. So y squared is equal to 4. Then we plug in the positive 2 right there. So this gives us 8. So y squared is equal to 8x. So this is the equation of this parabola that we have in this problem. Now we need to sketch the graph of this parabola. Now we remember that the distance from the vertex to the focus is P, and the distance from the focus to the ends of the latus rectum. So we're going to determine the ends of the latus rectum here is 2p. We can do that, or we can show the algebraic method in determining the ends of the latus rectum. So we're going to show the algebraic method here first. To determine the ends of the latus rectum, we're going to use this equation that we already have down here. So that is y squared is equal to 8x. That's the equation of the parabola that we have right here. Now we are going to plug in the value of P, which is where we got it from the focus. We are going to plug it into the x. So we plug it into the x. So this would come out y squared is equal to 8 times, we put in the 2 there. So this gives us 8 times 2 is 16. So y squared is equal to 16. Now we are going to solve for y. So then we go ahead and square root both sides. And this gives us, so y is plus minus 4. This tells us that the two coordinates would be located at, our x was 2. And then it's going to be on positive 4. And the other end would be on positive 2 and negative 4. So we plot this. That's going to be positive 2 and up 4. So it's going to be up here. And then the other end is located on 2 and negative 4. So it's going to be down here. Now the other way to determine the ends of the latus rectum is that if our P here is 2, we just double it. We remember we double it. So 2 times 2 is 4. So we go up 1, 2, 3, 4, and we go down 1, 2, 3, 4. Or you can use this method right here. So it doesn't really matter. The answer would still be the same. So then we go ahead and sketch the parabola with this equation from this problem right here. So this is the graph of this parabola with vertex at 0, 0, and a directrix of x equals -2. And the equation for this graph is y squared equals 8x. Now let's move on to the second example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We're supposed to determine the equation of a parabola with vertex at 0, 0 and with directrix y equals 11/4, and we're supposed to sketch the graph. Now, we are going to sketch this vertex and directrix first. So the vertex is at 0, 0. We label this as letter V, and then the directrix is 11/4. 11/4 is 2.75. So that's gonna be 1, 2, 2.75 is somewhere here. So we will draw the directrix. Okay, we remember that the focus is across this side right here. So from the vertex to the directrix, that the distance there is P, and the focus is also located P distance from the vertex across. So then this means that our focus is also 2.75 down below. So that's 1, 2, 2.75 is somewhere around here. So I can label this as our focus. So we can go ahead then and say that the P value that we have here is the same distance as this. But the catch here is that our P is negative. The reason why it's negative because it's below the vertex. So then we can go ahead and say that our P value here is -11/4. So then from here, we can say that our graph is opening downward since our focus is below the vertex. So it's going to open downward. This means that this is an example of case number 4. Since this is case number 4, and the general equation of a parabola with vertex at 0, 0 for case 4 is x squared is equal to 4py. We are going to plug in the value of p that we got over there into this equation. So the equation is this is how it's going to look like. So this is the equation of this parabola with vertex at 0, 0 and directrix at y equals 11/4. Now, our next task is to determine the ends of the latus rectum so that we can go ahead and sketch the parabola. So I'm going to show the work on how to determine the ends of the latus rectum down here. Okay, so the coordinates of the ends of the latus rectum would be this one. So what I did here was that I used the equation that I got over here and I plugged in the value of p into the y, and so I solved for x. And so the value for x is plus minus 11/2, or this is 5.5. So this was this end. So since that is negative, the other end is on the positive 11/2. So that's going to be positive 11/2. That's 5.5, and then negative 11/4. So it's going to be right here. So again, this is the coordinate of this end of the latus rectum, and this is the coordinate of the other ends of the latus rectum, so that we can go ahead and sketch the graph already. And so this is how it's going to look like. So this is the graph of this problem that we have up there, and this is the equation of this parabola. Now, the other way to determine the ends of the latus rectum is just to multiply the value of p. Now, remember, this is 11/4, which is pretty much 2.75. So 2.75 times 2 is 5.5. So we run 5.5 to the left and 5.5 to the right, and that will be the ends of the latus rectum, and we can just go ahead and sketch it. Or you can show the work this way. Both methods would still be correct. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!